Welcome back, Physics 30. This is the Laws of Attraction Lab. So I'll go through the instructions and some of the preamble that you likely do need in order before you can jump directly into this. So this activity, you'll investigate the quantitative nature of gravitational attraction. So we're going to look at the gravity force lab that we'll be able to find over here. Might as well just look it up right now. So if you go into Google, let's just type in PhET. And we want to go to the Sims, because that's where all the action is. And over here, we're going to the physics. And then we're going to look for something called Gravity Force Lab. Gravity Force Lab. I think it's about midway down. Looks crazy over here. There's a lot of neat demonstrations here. John Travoltage. I've never tried that one. I've always wanted to, though. I'm just a little curious about John Travoltage. Let's see. I went past it. Did I go past it? Oh, there it is right there. So I don't want the basic version. I want the good version, Gravity Force Lab. So click on that. Click play. Wait a few moments here. And hopefully it opens up. Cha-ching, there it is. Excellent. There we go. There we go. So this is kind of neat. We have a ruler here in which we can measure, so from center of these spheres at these, I don't know, these look like those Robaxison characters. So you can measure, so this would be 4.0 centimeters right here, wouldn't it? And of course we can move these. Ooh, there's a sound effect too, look at, I'm not sure if you can hear that, but there's definitely a sound effect here. And so you can see, look at the forces here. They're equal, which makes sense. Newton's third law. The force on M1 exerted by M2 is equal to this. And the force on M2 exerted by M1 is equal and opposite. Great. And the nice thing is we can adjust the masses here. We can, whoa, yes, we can make it really big. And then we can fine tune it. If we needed 175, we can easily do it. So this program has changed a little bit, which is good. We don't need to do any modifications to it at all. So that's what it consists of, basically making manipulations and measuring the resulting force. All right, so let's look back over here. So turn it on. And over here, please don't forget to do this. It's easy, Mark. Simply, I'm just going to get a pen here and star this. Label the following. So please label that. And for the most part, I think it looks the same. There may be a couple of different things here. So here, refresh button and refresh button. And this bar here is a little bit bigger on the actual one. You can see it has a bit more, but you should be able to handle that. Okay, so do that. And so the first part of the lab is just basically doing a few manipulations. What if I make this big? What's the biggest force I can get? What's the smallest force I can get? What are the movements I have to do? So you should be able to easily go through those first two pages and get that down. Now, of course, if we're writing force values, you may wish to write in scientific notation because the forces are relatively small here, as you can see. So, for example, this, if I place the decimal right here, then to get the original number, it's going to be 1, 2, 3, 4, 5, 6, 7. So 3.16 times 10 to the minus 7 newtons. So you can write things in terms of scientific notation. Just so you don't have to have all those zeros there. All right, the actual lab deals with this. So dynamic force 1, vary the mass. And then part 2, what we're going to do is vary the distance. Okay, so for varying the mass, of course, we're going to keep the distance constant. If I look over here, it says reset. Move the blue mass back to the 0 point on the ruler. Move the ruler so the top edge is slightly, yes. Set the mass 1 to be 12 kgs. Set mass 2 to be 12 kgs. And make sure that they are 4 meters apart. So they are exactly. So, and again, measure through by the centers. So I'm going to have to move this guy. There we go. And to change it to 12, easy peasy. Then fine tune. Move it close, then fine tune. And then, of course, here you have your mass. So let's see, 6.01 times 10 to the, well, this is 3, 6, 9, 10. 6.01 times 10 to the minus 10. So, hey, we can write that down right here. Look at that. We'll get a free mark. 6.01 times 10 to the minus 10 newtons is the resulting force that we get when we have these settings here that we needed to set up. There we go, that's neater. All right, so we'll consider that FO or F naught, or the original force, the OG, the original force at those settings. Okay, and what would the new force be if I left everything the same? If I multiplied everything by 1, so 1 times 12 is 12, 1 times 12 is 12, 1 times 4 is 4, well, of course it'd be the same thing, wouldn't it? So the new force divided by the old force, because I would have 6.01 times 10 to the minus 10 divided by 6.01 times 10 to the minus 10, so of course that would give me 1. So that's the baseline force, is this, okay? Now what we're going to do is do some modifications. So double the red mass, determine the new ratio. Hint, the answer is 2. Record this value in the table below beneath M1/2 times M2. And then do the rest of these. Okay, so let's look at it. Now, we should likely change a couple of things here. So let's keep this as, okay, for M1, if you don't see anything happen there, this simply means multiplying by 1. But over here I was told, well, let's double M2. Okay, so if we double M2, that means it's going to be at 24. Okay, so now I get 1.201 times 10 to the minus 9. Now, if I take that, so what you need to do here, you don't need to record that number. What you need to do is take this force value, which is your new force, type it in your calculator, and then divide by the baseline force, which of course is the horse with no remorse, is that. And we should see that that answer is exactly doubled. So we want to see the force, by what factor does the force change? Okay, so what this means, it gets 2 times bigger. Okay, and then moving on here, let's just make sure we know what modifications do. So we're going to double M1, double M2. Now this is, now M1 is the original, right? M1 and M2 are the original settings. So when I'm taking 2 times M2 here, I'm not doubling, they're already doubled here, I'm just doubling what it was originally, okay? Over here, we're multiplying by 1. Here, we're dividing by 2. Divide by 2, or, and of course that is the same thing as multiply by 1/2. All right, so you can think of it as either one, divided by 2 or multiplied by 1/2. You may want to think of it as multiplied by 1/2, because it'll make the next page a little bit easier if we're simply multiplying by things. Okay? All right, and then let's see, some of these other ones here. Again, we have another one here. Oop, I ended up with yellow here. Let's fix that up. So here I'm going to be multiplying by 1/2, multiplying by 1/2. So times by 1/2, times by 1/2. And at the bottom one here, times by 2, times by 1/2. Over here, times by 1, times by 3. And then, of course, you write down the force and divided by the original one. So here we're multiplying by 1/3, and here multiplying by 6. All right? So those are the modifications that you're going to be doing, and writing down the force factors, not the new force. You take that new force divided by the baseline, and you get by what factor it changed by. Okay? And that leads to this. Describe the relationship. Now over here, the symbol theta, alpha means is directly related or proportional to. Okay, so when you figure out which one of these is the one, is it this, this, or this? Which is the one that describes my relationship from the previous page? You'll check off which one you think it is, then say force is directly, directly related to, is it the sum of the masses, the product of the masses, or the quotient of the masses? Okay, so you have to figure out which one is it. All right, so that is the setup for that. So of course what you'll see here is the M1 and the M2 are the factors that we're talking about. The factors. Okay, so for example, if I go back to that previous page, and let's say, so this first one, let's say I get, let's do this one. So this one was multiplied by 1 and multiplied by half. Now, whatever number I get here, to get that number using these numbers, the 1 and the 1/2, do I add those two together, the 1 and the 1/2? Or do I multiply the 1 and the 1/2 together? Or do I take the 1/2, or what was that first one? The first one was 1. So I take that 1 and divide it by 2. So which one will give me the force, the overall result, the force factor? So basically, what do I do to these numbers to get this? What do I do to this to get this? What do I do to this to get this? So that'll help you figure out what the relationship is here. Okay? So that's what you do for the first one. And this part 2 is very similar. So again, you reset things to how it was originally. So this force, this initial force will be the same as the previous one. And then again, we're going to be doing some manipulations here. So with this first one, we're going to double the D. Over here, we're going to take 1/2 of D. Over here, we're going to take 1/4 of D. Okay? And then again, do that. And then we'll combine both of those together. So force is related to what in terms of distance? Okay? So I think I'll stop there. I will have a second part to this video, or second part video to show what you do in the post lab. Okay, so I'll have that uploaded soon. All right, see you again.